When the scale factor of the sides was 2, then the value of the ratio of the areas was. So for this one, we need to go back to our example 1. So when the scale factor was 2, the actual area ratio was 4. The next one, when the scale factor of the sides was 1/3, then the value of the ratio of the areas was, that would be going to our second example here. Oops, get it in the screen. So when our area was 1/3, the value of our areas was 1/9. And the last one, when the scale factor of the sides was 4/3, then the value of the ratio of the areas was, and that would be looking at our example 3. So when this scale factor was 4/3, our actual area was 16/9. This is based on these observations, what conclusion can you draw about the scale factor and area? So we're trying to compare this scale factor to the area and how they relate. Hopefully we start to see that if we take our scale factor, so like on our first example 2, and do 2 times itself, or 2 times 2, we get the area of the ratios, or ratio of the areas, sorry. Same thing like on the second one, if we have 1/3 and we times it by 1/3, we end up with that value of the ratio. And then down here on the last one, 4/3 times 4/3 equals 16/9. Our last question here says, if the scale factor of the sides is r, so if this number here is r, then the ratio of the areas is, so we took each of these and timesed it by itself. So if these are r, we could then say the area is r times r, or we could write that with an exponent of 2 and we could say that it is r squared.